Okay, let's do this problem. Given, find, and of course we have to do solve. Now, zoom out a little bit. So I have a force acting on these two objects. They're on wheels, so there's no friction in this problem. And I got a 15 and a 45 kilogram cart that are up against each other. We want to know what is the acceleration here. Now you're going to get problems like this on the AP test. They're going to be disguised. They're not going to be quite laid out quite this well for you. But if you can just take a step back and just write down what you know, what you're supposed to find, and all that, you'll have more success. You'll get more partial credit. Okay, so first thing I want to do is I want to find the acceleration given a force and a mass and all that. So that means I need to use a procedure. So I'm going to draw a free body diagram. Since this force is accelerating both of these masses, I'm going to draw one free body diagram. Like step one of the procedure's already been done. I did step one for you, right? Now this is going to have a force like this. It's at a 20-degree angle like that. And what other forces are acting? Well, I've got a normal force from both of these guys. I'll just combine them into one normal force. You've got the normal force. You got mg. And that's it. These are the only forces acting. So, because there's no friction. All right. If there was friction, you'd have two different frictions because you have two different objects here and it'd be more complicated. Okay, so that's step two. Draw the free body diagram. Step three. I'm going to say this is my x direction. This is my y direction. And I'm going to take this force and break it up into its x component and y component. And this is going to be F applied. This is FA cosine theta, and this is FA sine theta. Now it should be negative 20 degrees, but it doesn't really matter for this problem. Okay, so now I'm done with step three. Now let's do step four. I want the acceleration. It's only going to accelerate in the x direction, so I only need to sum the forces in the x direction equals ma in the x direction. Well, what's the force in the x direction? FA cosine theta equals ma. So I can solve for A. A equals the applied force times the cosine of the angle divided by the mass. So let's plug in our values and we'll get our acceleration. This was given to be 30 newtons. The angle is negative 20 degrees. And don't worry, the cosine, if you use cosine 20, you'll get the same answer. But now, what is the mass? Do I use 15? Do I use 45? Yes, I use both of them because this is the mass of my free body diagram. It's all of the mass. So what is 15 plus 45? That's 60 kilograms. And so the acceleration of my system here is 30 times the cosine of, and I am in degrees, negative 20 divided by 60. And I get 0.470 meters per second squared. Is that what you guys got? Okay, good. So yeah, we got the first part. Now, the second part is deceptively easy if you know what to do. We want to know what is the force of 1 on 2. Well, let's draw a free body diagram of object number 2. And so this is part B. Well, here's object 2. It's 45 kilograms. I've got its weight pulling down, right? And I've got a normal force pushing up. And I would only need to worry about this if there was friction in the problem, because then I need to know what the normal force is and all that. But I don't need that right now. because it's on wheels, there's no friction. But we do have the force of 1 on 2. 1 on 2. And that's what we're trying to find. So if I sum the forces in the x direction equals ma in the x direction, there's only one. The force of 1 on 2 is equal to ma. Now what is m? 45 kilograms. And how fast is it accelerating? 4.70 or 0.470 meters per second squared. So the force of 1 on 2 is equal to, let's see, 45 times 0.470, and we get 21.2 newtons. Did anybody get that? If you got that, you're in good. You're good shape. Because that was not, that's kind of going back a ways. And all right. And now, by the way, what is the force of 2 on 1? If I was to draw a free body diagram of just this guy, it would be 21.2 newtons to the left instead of to the right. Because for every force on one object, there's an equal and opposite force on the other object. So the force of 2 on 1 and 1 on 2 are equal and opposite, just in case they ask. Now, let's do part C. We want the final velocity using kinematics. Well, we don't know time. So I'm going to use a kinematic equation that doesn't have time in it. V final squared equals V initial squared plus 2a delta x. Now, by this time, maybe you've got these memorized. If you've used them a lot. You will have, on the AP test, you will have an equation list that has these on there. All right. So, well, this is 0. So this is 2 times, and what is this, 0.470 meters per second squared. And the displacement was given to be 3 meters. And so V final is equal to the square root of all that. That's the square root of, well, what is 2 times 0.470 times 3? That's 2.82 meters squared per second squared. Notice, meters squared per second squared. But then you take the square root of it, which on my calculator just raise it to the 0.5 power. And my final velocity is 1.68 meters per second. Anybody get that? Got all the way there? Awesome. Okay. Now, for part D, we can use energy to figure this out. And what we're going to see is it's going to look very similar to this. But I want you to see that that energy concept works. Now what, am I still on screen? Yeah, okay. So for part D, well, I'm going to use the work-energy theorem. The work done by the net force is equal to the change in kinetic energy. You remember that? The work-energy theorem. The work done by the net force is equal to the change in kinetic energy. Well, what is the work? Well, that's work is equal to force times displacement times the cosine of the angle between the force and the displacement, which is, like if I look at my picture, the force is 30 newtons, the displacement is 3 meters, and the angle between them is 20 degrees. So that's going to be 20 degrees. And this is equal to K final minus K initial. But what is K initial? That's delta K, is K final. K initial is 0, right? It was given that the initial velocity was 0. So this is going to be 0. So this is 1/2 mv squared. So I'm going to solve for v now. So v is going to be equal to F times delta x times the cosine of the angle. That's the work done. I'm going to multiply it by 2 because of that 1/2 right there. Times 2, divide by the mass. And then I'm going to take the square root, or raise it to the 1/2 power. So now I can just plug in values. But notice what we've got in here. I take the force and I divide by the mass. What is the force divided by the mass? Well, that's the acceleration. Well, force times cosine 20 divided by the mass. That's the acceleration that we got. That if you go F times this divided by that, that's your 0.470. And then you multiply that by 2 and delta x, that's just what we have right up here. Now that shouldn't surprise you too much if you remember how we derived the work-energy theorem. We used the fourth kinematic equation to derive that and to define what kinetic energy was. So it kind of makes sense. Well, we're ready now to plug in values. The force is 30 newtons times delta x, 3 meters, times the cosine of the angle, 20 degrees, times 2, divided by the mass. Well, it's all the mass, not just the 45. It's all of the mass has kinetic energy. So that's 60 kilograms. And we're going to raise that to the 1/2 power. So let's do the calculations. 30 times 3 times the cosine of 20 degrees times 2 divided by 60. And then I take the square root of that. And I get 1.68 meters per second. Woohoo! Same as up here. I just want you to see that it all works. I mean, it works. It all tells us the same thing. Now, let's use the impulse momentum theorem. Was that E? Oh man, went all the way to E. That's not nice. Well, what is the impulse momentum theorem says that the net force times time will equal the mass times the change in velocity. Well, let me rewrite this. Hold on. Sorry. Times the change in momentum. Now, we really wouldn't use impulse momentum to solve this problem because the other two methods that we've done are better based on what's given. But what if instead in the problem, instead of saying delta x equals 3 meters, what if I told you t equals 5 seconds? Well, then using the impulse momentum theorem would be easier. But now, let's figure out what these pieces are, though. The net force is equal to 30 newtons. Let's see. Times the cosine of negative 20 degrees. Right, that's the net force. Because the vertical component of that 30 Newton force is being canceled out by the normal force. So that's 30 newtons times the cosine of negative 20 degrees, and you get, oh, I already did that, 2.82 newtons. Now, we don't know what delta t is. but we know what the acceleration is. We don't know the final velocity. That's actually what I want to find. So I'm going to use the third kinematic equation to solve for time. Whereas delta x equals v naught t plus 1/2 a t squared. So this is 0. So if you solve for t, you get 2 delta x over a. And you have to take the square root. And we've done this many times, solving for t for something like this. That's 2 times 3 meters. And what was our acceleration? 0.470 meters per second squared. So 2 times 3 divided by 0.470 equals, raise that to the power of 0.5, and we get 3.57. So now we know what our delta t is. Now let's say this is equal to the mass times the change in velocity. So that's the mass times the final velocity minus the initial velocity. But our initial velocity is given to be 0. So our final velocity is going to be equal to the net force times time, or delta t, which is this, divided by the mass of my object. Well, the net force is 2.82 newtons. The time is 3.57 seconds. And the mass is 45 kilograms. Not 45, what is it? How much stuff is getting its momentum changed? 60 kilograms. All of the mass is getting its momentum changed by that force. So, oh, there's a mistake here.
Should be 28.2.
Yeah, 28.2. Is that right? Yeah, I just read the calculator wrong, sorry. And if you see me making a mistake, I make mistakes all the time, so just speak up, just politely point them out. I have no pride left, don't worry. So 28.2 times 3.57 divided by 60, and we get, yay, 1.68 meters per second, the same answer. Woohoo! Let's zoom all the way out. All the way out, zoom all the way out. See the whole thing. Can we get the whole thing on here? Yeah. Almost. So anyway, study this problem, and you'll be ready for that part of the AP test. Free response. Okay, that is all.